So one of the really cool new additions in the Java 8 specification is the way in which you loop over collections. There are different ways in which you can loop over a collection. There were a couple of ways you could do it in Java 7. Java 8 introduces a whole new concept called streams, which let you iterate over collections in a brand new way, and it has a lot of advantages. The biggest advantage is you can kind of combine that with lambdas and have really, really expressive programming. I'm going to give you an example of the looping that I'm talking about by creating a new class here. I'm going to call it collection iteration example. And this is something I'm going to have a main method on. And here, I'm going to initialize a simple people collection. So this is something that we've been using all along, right? It's a list of person objects. Now, how do you loop through this list? There are typically a couple of standard ways to do it. The first one is the ever popular for loop. So you have a for loop, and let's say I want to print this to the console. I'm going to say system.out println people.getAfi. So this is going to print that particular element to the console, and it's going to do this for every element here. This is using the for loop. Now there is another way in which you can loop through, which is using the for each loop. That was a newer addition to the language. So the way to do that is to say for and then person p in people. What you can do is system.out.println of p. Now both these loops, the first one and the second one, are both loops that iterate over the people collection, and they print each person. I'm just going to run this to make sure this works, and here you see both these loops result in these people getting printed. Now here's a common thing about both these loops, and these are what are called external iterators. What do I mean by an external iterator? You're basically writing the code to perform this iteration imperatively. You're basically telling the compiler that you want to iterate over this. You're controlling the iteration. You're writing code controlling the iteration. So here you say you're initializing an I, you're saying, okay, this is where I start, and then for each increment, you're incrementing it yourself, and you're setting the end point where the loop should end, and you're specifying what you need to do for each element. Now, here's the other example for looping through where things are a little bit simple. You're not maintaining an index, but you're still telling the compiler to do all these things. You're telling the runtime to do all these things. You're saying, okay, get this per people, and for each person in there, create a variable called p, assign it to that, and then you're using that p variable in order to perform an action. So these kind of iterations, these two methods, are called external iterator in the sense that you are managing the iteration process. You are controlling this. Now, what has been introduced in Java 8 is a new way of iterating called internal iterators. What happens there is you're basically giving the control to somebody else. You're basically telling the runtime, hey, I want to iterate over this people list. How the iteration happens is really up to the runtime. You're not controlling it. For here, you're basically saying, I need to start from here, I need to end from here, I need to go in that order. And even here, you're basically having a particular order in which this thing executes. So you are controlling the iteration. Now, there is a third way to do this in Java 8, where you're not controlling the iteration. You're basically telling your intent to iterate over this. You're basically telling the runtime, hey, I want to iterate over this. How the iteration happens is up to the runtime. You are not controlling it. And the way to do that is by calling a new method on each of these collections. So this is a new method that's been introduced in Java 8. So every collection, like the people collection over here, which is a list, has a new method called for each. Now, for each is a method that takes in one argument, which is a consumer. It's an instance of consumer, and it takes in a person. It's a generic interface with person. So what you can pass to this is actually a lambda expression. So this is the new way of executing an iteration. You're basically telling the interpreter here, for each element in this person, I want to execute a particular lambda expression. Now, how that lambda expression gets executed for each person is really up to the runtime. You're not telling, hey, I want to start from the beginning and finish at the ending. You're not instructing how the loop should be executed. You're not instructing the order in which it needs to happen. You're basically telling, make sure that this lambda executes for each and every element in this people. How that happens, it's not your concern, right? You're basically telling the runtime to do this. Now, what you can do is pass that lambda expression here, and the runtime is going to execute that lambda expression for each of these elements. How it does it doesn't matter, right? So this is a new way of doing things. So let me create a lambda expression, which is the equivalent of the system.out.println. So the lambda expression is going to be something that takes in one input argument, which is the p, that's the person. And then given that input argument, I want to run system.out.println of p. So this is the lambda expression you're passing to the for each. So this is a consumer. Remember, the for each method takes in a consumer because it needs to consume each instance that the loop is going to go through. So whatever you pass to the for each is going to get called for each element in people, and then that element is going to get passed to that lambda expression. So that's the element you're catching over here. Now, given an element, you want to execute some code, which is your system.out.println of p. So this should work pretty much the same as the other iterations. Let me paste this here using lambda for each, and to execute this. Now here you see this is also printing each and every element over here. So let me change this to a for in, because this is kind of confusing when you compare it with the for each over here. So this is what we used to refer to, or at least I used to refer to as for each. Some people refer to as for in. This is the new for each loop in Java 8. As you can see, this is super crisp and super easy to read. You're basically saying for each element here, execute this. Now, since this is something that can be substituted with a method reference, you can see there is an element here, and that element is simply being passed through. So this can be a method reference. I'm going to change this to system.out :println, call this. Right? This will work just as well. If I were to execute this, this is going to work just as well. So this is the new for each loop in Java 8. Now, why is this a big deal, and why am I talking about this in the course on lambdas? Well, this is a perfect opportunity for us to use lambdas. As you can see, I'm using a method reference here to pass in a function, and that function is going to get executed for the for each. And again, I want to highlight the difference between these external iterators and this internal iterators. Now, the difference and the advantage of using something like this is that this makes it very easy for the processor to run in multiple threads. Given that this is something that you are controlling, this is essentially sequential, right? You've written all the steps. I starts from 0, I goes all the way to people.size -1, and for each step it is doing this. So it is essentially sequential. This is also sequential. But the magic of this is you're basically saying, I don't care about the order. You just have to run this for each and every element. How you run it is up to you, right? So this makes it possible for this loop to execute in parallel. Let's say you have 2 processor cores. The runtime might say, okay, I'm going to execute the method for these 3 elements in the first core and these 2 elements in the second core. That is perfectly possible. So that makes it possible to have multi-threading and parallelism. So this doesn't necessarily execute this function in parallel, but you're basically using a programming model that is consistent for other operations which can be executed in parallel, and that's the whole point. That whole advantage is unlocked by this new approach.